Welcome to Lesson 6 on intermolecular forces. Our lesson objectives determine the type of intermolecular force that exists between covalent compounds and determine the effect of intermolecular forces on melting and boiling point. Now, we've already covered the force of attraction between atoms. Those are the covalent or ionic bonds, for example. But we have not talked about the force of attraction that occurs between neighboring molecules. These are called between molecular forces, or IMS for short. These are weak forces of attraction between molecules, or covalent compounds. And so, for example, HCl, it's a covalent bond, and the attraction between the chlorine of one molecule and the hydrogen of another is called an intermolecular force. This is a weak attraction. So the weakest of these intermolecular forces are called dispersion forces. These occur between nonpolar molecules. Now, initially it was thought that there was no attraction between nonpolar molecules because they are nonpolar. They're not polarized. But then it didn't explain the existence of certain molecules that exist in the solid or liquid phase. For example, diatomic bromine is a liquid at STP, and diatomic iodine is a solid. And of course, fluorine and chlorine as a diatomic molecule would be gas. And so, what is holding bromine or iodine in these solid or liquid phases? And so there had to be some force of attraction, although very weak. And so it was concluded that since electrons are moving around the atom at any one given moment, the electrons will be on one side of the atom versus the other. And so it sets up a very temporary dipole where polarity is established, where there's a slight negative end or side and a slight positive. And of course, then opposites will attract. So there will be a very weak intermolecular force of attraction between the slightly positive and slightly negative side of this molecule. Again, because they're initially nonpolar, this is very temporary. And so it's a weak attraction. But as we start to add more and more electrons, as we go down group 17, more electrons would mean a stronger temporary dipole, which means a stronger intermolecular force. The next strongest intermolecular force we have is the dipole-dipole. And it's stronger because it occurs between polar covalent molecules. Since these molecules are polar, they have an established dipole. It's already set up that there's a positive side and a negative side of the molecule, and therefore the opposites will attract. So the intermolecular force would occur between iodine of this molecule and the hydrogen of this one. The greater the polarity, the more polar it is, the stronger the intermolecular force. And in fact, if it gets so strong, we have a unique name for that, and that is called the hydrogen bond. This is the strongest of our weak intermolecular forces. It is an extreme dipole due to the most electronegative elements being involved, which are oxygen, fluorine, and nitrogen. So they're going to set up the most polar substance we can have, and it's going to occur between fluorine, oxygen, and nitrogen of one molecule and hydrogen of another. So the most common example we have is water. If you look here, water is a polar molecule. We have a dipole set up where the oxygen is the partial negative side and the hydrogens are the partial positive side. And you can see that the hydrogen, this partial positive side, then is attracting through an intermolecular force called hydrogen bonding to the oxygen, the slightly negative end of this molecule, and so on and so forth. So it creates this structure here, and this is the reasoning behind cohesion and adhesion of water, surface tension of water, which we talked about, and the relatively high melting and boiling point of water compared to other covalent compounds. It's due to this stronger intermolecular force. And hydrogen bonding is the only one you're responsible for on the Regents exam. And a good way to remember this is hydrogen bonding is Phan. So H bonding, H for hydrogen, is Phan, and these are your three elements, F, O, or N. So in the case of water, it satisfies that. It has H, and it has our O in the neighboring molecule. Another example would be hydrogen fluoride, HF, would be another example of a substance that had hydrogen bonding. So let's check your understanding. Can you determine the type of intermolecular force that exists between covalent compounds? Now lastly, I talked about it already, but I want to really highlight the idea that intermolecular forces affect the melting and boiling point. the stronger the intermolecular force of attraction between neighboring molecules, the greater the melting and boiling point of that substance. So for example, if I wanted to take this solid chunk of H2O, which we call ice, and I want to melt that and then turn it to a gas. In order to do so, I need to break free these molecules of their neighbors. So I need to break these intermolecular forces of attraction. And since water has hydrogen bonding, which is the strongest of this weak attraction between particles, it's going to have a relatively high melting and boiling point. A nonpolar substance has a weak attraction, a very weak intermolecular force, and therefore would have a very low melting and boiling point. So the take home is, the stronger the intermolecular force, the higher the melting and boiling point. So any substance exhibiting hydrogen bonding would have the highest melting and boiling point in comparison to the other molecules. So here's an example. Which has a higher melting point? Would it be hydrogen or water? And the answer is going to be H2O, because H2O has hydrogen bonding, where H2 exhibits only dispersion forces of attraction. This is a nonpolar molecule, so very weak connection with its neighbor, versus water, which has that hydrogen bonding, which is much stronger. So let's check your understanding. Can you determine the effect of intermolecular forces on melting and boiling point? At this point, you should determine the type of intermolecular force that exists between covalent compounds and determine the effect of intermolecular forces on melting and boiling point.